like all of them, I would always recommend that you draw it. So this is problem 3 in this exercise that we're looking at, exercise 98 I think, is that right? Yeah. So if we draw it, it doesn't matter whether the angles are correct, they don't look right, just draw your triangle ABC, and in this particular case, if you look at the way they talked about it, they're not using the letters A, B, so they're using D, E, F. So let's stick to there. So, okay, let's call this D, this E, and this F. So therefore, that side E, that side D, and that side F. So then we can put on what we know. We know that little d, the side D, is 17 centimetres. And we know that side F is 22 centimetres. We know the angle F is 26 degrees. And we've got to find the other sides, basically. So the other side, side E, and the missing angles. So, having drawn it, ask yourself the question, can you use the sine rule? Answer, yes, because we've got a ratio right down here. Yep, we know that side, and we know the angle opposite it. If we know one of the ratios, we can use the sine rule. We've got to find angle E, this one, angle D, that's this one, and side E. At the moment, what can we find? Given what we know, what can we find? Angle D, right, because we know side B, so ratio-wise, we know this ratio, and we know this side, so we can find angle D. So the first thing to do is find D, because that's findable. We know the information to do that, angle D. How to start off, yeah. With right. Yeah. Well, to make E. Right, I see. Okay, well, what you need to do then is just to think to yourself, okay, I know this ratio, so the only thing I can find after that is the thing that's opposite, the other thing I know. If I know that side, then the only thing I can find at this point is the angle opposite, ratio-wise, okay? That's what's got to be there, that's the thought process. So, I'm after an angle, so I'm going to write the ratio with the angle on top, instead of writing it side over angle, I'm going to write angle on top, because it's an angle I'm after. So, sine of angle D, which is what I'm after, over the side opposite it, equals the ratio I know, which is sine F over side F. So I know those, so I don't necessarily have to write this intermediate step, but what I certainly need to write is sine D, what I'm after, over what I know, which is 17, equals sine of F, which is sine 26, over side I know, which is 20. So I put in the values. So now we just multiply both sides by 17, because I'm after the sine D, that's what I'm after, and I'm after the angle, so sine D equals sine 26 over 22 times by 17. Multiply both sides by 17. The next step, which we looked at just before the break, if I'm after the angle, angle D, that's what I'm after, equals the inverse sine of this, sine 26 over 22. So again, I can try and do that in one hit on the calculator. And that hopefully will give you the answer. Oh. So the answer's in the book. From that point, you can check it now and see if you get the right answer. Once we've got the angle, then we can find the other stuff. Once I've got this angle, whatever that comes out to be, angle D here, then I'm away because I can find the missing angle, which is this one, and then once I've got that, I can find the other side. This here means it's the inverse, the angle whose sine is this. I'm after the angle. So if you're after the angle in any triangle thing, it's this inverse sine directly to the angle. I'll come over there and we'll have a look at one or two so you get it, okay? Right, but that inverse means the angle whose sine is. Record this then. So the cosine rule, used when we know all the sides but none of the angles, or we know two sides and an angle, but we don't have one of the ratios. For example, in this one we know all three sides but none of the angles, or we know two sides and one angle but none of them give you a ratio. In these examples we use the cosine rule, and here is the cosine rule. Again, it applies to a triangle using the notation we've been using before. So for a triangle ABC, where we label the sides, little c, little a, and little b, this is the cosine rule. A squared, so the side A squared equals the other two sides squared now they're together, b squared plus c squared, but then minus 2 times bc times the cosine of angle A. That's the cosine rule. Just to point out one or two things about this thing. If you look in textbooks, you might see this written in three forms. For example, this is set up to find side A at the moment. What if we want, so that's this side A. What if we want side B or we want side C? Well, you could write B squared equals C squared plus A squared minus 2CA cos B, and C another way. But I don't ever do that. I just think, okay, if that's the side I'm after, let's call the side I want A. And then you'd only have to remember it in one form. So that's one thing. We call A the side we're after, and then the other two sides can be B and C. Okay? And the other thing to note is that the angle in this formula is always the one opposite the side we're after. So the angle A is opposite the one we're after. Okay? And then we just apply the rule. We need to know what these other two sides are, B squared, B and C, and the angle opposite it, and then we can find it. Okay? If we're after angle A, that means we've got to rearrange the formula for A, and that's not that straightforward. So often people try and remember what it is. So I'm going to write down what that formula is for A, and those of you who are interested, when you want to go through the algebra, can try and show how you get from this first formula to the other one. I could go through it. I've done similar things, but at this point, let's just write down the formula, and you can try and prove it for yourself. So another way of writing the cosine rule is set up to find the angle. So it's equal to cos to the minus 1, because it's the angle whose cosine is, right, what I have to do, I have to go b squared plus c squared minus a squared all over 2bc. So that's set up now to find the angle A. So if I'm after an angle, I use this form. If I'm after a side, I use this. At this point, one other little pitfall that might occur that's worth pointing out at this stage is, if you look at this first formula here, it's set up to find side A, as written there, but actually you're not finding side A, you're finding A squared. So you have to remember, once you've used this formula here to find the missing side, you square root the answer. So in some ways, it's worth remembering that actually A equals the square root of for that. E squared plus c squared minus 2bc equals a. So you could put that into your calculator like that using the square root button, but you won't make that error. So that's another little tip for using this formula. Well, let's look at an example and see how we get on. Okay, look at this question. Can I use the sine rule? Because there's no ratio in there. I know this angle, but I don't know. I know this angle, but I don't know the side opposite it. Button there. So, yeah, I know this angle, but I don't know the side opposite it, so I don't know that ratio. I know this side, but I don't know the angle opposite, so I don't know that ratio. And likewise, I know that side, but I don't know the angle opposite, so I know none of the ratios, therefore can't use the sine rule. In a real problem, that's just the question you have to ask yourself. You know, it's not always says use the cosine rule to do this. You need to decide which rule to use. And the sine rule is the easiest to use, so if you can use the sine rule, use it. But in this case, you can't. So we have to fall back on the cosine rule. The cosine rule is this, and we're after a side, so we're going to use this formula, a squared equals b squared plus c squared minus so on. What's important about that formula is what a is. So a is going to be, remember, in that form, we're going to let a be the side we're after, because we're after that side. So therefore, it doesn't matter which we call B and which we call C, so B and C will be the other two sides. So in other words, to use the formula, we just let the side we're after be A, and then the rest follows. And the angle that we're interested in is always the one opposite the side we're trying to find. So the cosine rule says A squared equals B squared plus C squared minus 2BC plus A. And eventually you write it enough times you remember it. So E squared, which is what I'm after, equals the other two sides, 25 squared plus 35 squared, so the other two sides squared, minus 2 times the other sides, 25 times 35 times the cosine of the angle opposite what I'm trying to find, which is 64 degrees. Because at this point I put in the actual letter that's in the problem. I might call it X, I might call it anything. And now you can do that in one hit on the calculator. So work out what that is. So answer comes to 1082, but that's not E, is it? What is that? Right, that's E squared. So don't forget, remember that pitfall I mentioned? E is actually the square root of it, which is 32.9. So 32.9 or 33.2 significant figures. And the unit, I think it was given in centimeters, no, millimetres. So millimetres. 3 significant figures. That's a good, if you think you might forget the square root at the end, which is a very easy mistake to make, then you could put the square root in the calculator. So in other words, you could say E equals the square root of 25 squared plus 35 squared minus 2 times 25 times 35 times cosine 64. Try that, okay?